The Explorer tests have been voyaging through the universe for more than 45 years, and we can't help thinking about what will, as a matter of fact, happen to these two tests in the far-off future. Will they truly come to a far-off star system and perhaps experience aliens there? And where are NASA's Trailblazer tests, which were also launched during the 1970s? Explorer 1 and 2 were launched in 1977 to make use of an extraordinary arrangement of the outer planets. Jupiter, Saturn, Uranus, and Neptune were closely related and were as simple to just reach as they are every 12 years. NASA immediately put together two tests that have since made world history. Explorer 1 and 2 first ventured out to Jupiter and Saturn as part of their original mission, with Explorer 2 also investigating Uranus and Neptune for the first time. Scientists shot tests through the nearby planet group in record time as part of the so-called gravity assist maneuvers. Only a few years after launch, the two tests gave photographs and scientific discoveries of Jupiter and Saturn for the first time. Explorer 1 captured the first high-resolution pictures of Jupiter's iconic Great Red Spot and recognized it as a storm. The test found active volcanoes on Jupiter's moon Io and reported the complex ring systems and moons of Saturn. Explorer 2 continued its journey and became the first spacecraft to inspect Uranus and Neptune up close. It captured the giant ice planet Neptune and discovered new moons and rings around Uranus. Explorer 1 was now on its journey to the outer reaches of the solar system, powered by a plutonium-238 radioisotope thermoelectric generator. The spacecraft has now flown more than 24 billion kilometers into open space. Explorer 2 followed at a closer distance and is now also flying through the interstellar medium. Both tests are still sending data about particles, cosmic radiation, and magnetic fields regularly. After more than 45 long years of movement, the energy sources are slowly depleting, and NASA has been struggling with a few breakdowns of the space veterans recently. So far, NASA engineers have repeatedly managed to get the two explorers up and running again. The specialists have made successful long-distance repairs, and if all goes well, we can expect measurement data from the interstellar medium for the rest of the decade. However, what will happen after the last radio contact with Explorer 1 and 2, when the batteries have finally given out? The ghosts of Explorer 1 and 2 will still be flying, but they will not be able to send additional information to Earth. Calculations have shown that in around 40,000 years, Explorer 1 will pass by the area of the star G445. By then, it will have traveled a distance of 17.6 light-years. Explorer 2 will pass near the bright star Sirius in 296,000 years. Neither of the tests has a direct objective. Rather, they are floating pretty much randomly through the system. They might fly for billions of years, and no one knows when or if the tests will ever be found by anyone. If they fall into the hands of an extraterrestrial civilization, the two tests have a brilliant record on board. In fact, the plates are not completely made of gold, but rather plated copper plates. They contain sound recordings of greetings from humans in various languages, as well as pictures, sounds, and music from Earth. So, when their mission reaches its conclusion, Explorer 1 and 2 won't just be decommissioned scientific instruments, but cultural ambassadors carrying humankind's heritage into the infinity of space. Where are the Trailblazer 10 and 11? Trailblazer 10 and 11 are often forgotten in all the excitement surrounding Explorer, but these two are still out there in space. Trailblazer 10 and 11 were two of the first probes to explore the solar system. Trailblazer 10 was launched on March 2, 1972, and Trailblazer 11 followed on April 6, 1973. The primary objective of both was to explore Jupiter and Saturn, after which they were to go on into the outer reaches of the solar system. In addition to their visits to the two gas giants, the two missions were also designed to explore how interplanetary space behaves at vast distances. Trailblazer 10 was the first probe to successfully cross the asteroid belt between Mars and Jupiter, paving the way for Explorer 1 in December 1973. It passed Jupiter at a distance of around 132,000 kilometers. Trailblazer 10 provided the first close-up pictures of the gas giant and sent data about Jupiter's radiation, its strong magnetic field, and its violent atmosphere. After that, it continued its journey into interstellar space. Tragically, The probe was no longer able to report the transition from the solar system into interstellar space. In January 2003, Trailblazer 10 sent data about cosmic radiation and the solar wind for the last time. Today, it is a distance of about 130 astronomical units, or roughly 19.5 billion kilometers from Earth, heading toward the constellation of Taurus. Trailblazer 11 also explored Jupiter and, in December 1974, provided unique data from the inner radiation belt of the gas giant. To do this, scientists performed a risky maneuver, getting so close to Jupiter that it was a remarkable achievement that Trailblazer 11 survived this close encounter in one piece. Jupiter's radiation is among the most extreme in the solar system. After completing its mission to Jupiter, Trailblazer 11 went on to Saturn, where it analyzed Saturn's magnetic field and provided the first measurements of the temperature of its moon Titan. After its primary mission to Saturn, Trailblazer 11 continued its journey toward interstellar space. Communication was cut off in November 1995 when its power supply became too weak. Today, Trailblazer 11 is likely around 103 astronomical units from Earth, which is about 15.4 billion kilometers. In many millennia, Trailblazer 11 will probably reach a star system in the constellation of Lyra. Like the Explorers, the Trailblazer probes also carry greeting messages for potential encounters with extraterrestrial species, ready as interstellar diplomats. Each of the two probes has a gold-plated aluminum plaque in their equipment, the so-called Trailblazer plaques. These plaques feature schematic representations of humans, Earth, and the location of our solar system in the Milky Way. The Trailblazers were the first probes to send back data from the outer reaches of the solar system, followed by the Explorer twins. Then, it went quiet for a while as NASA focused on exploring other destinations until New Horizons was launched in 2006. New Horizons, Mission to Pluto and Beyond. With New Horizons, NASA launched a mechanical wonder. The probe was one of the fastest spacecraft ever launched, taking off from Cape Canaveral on January 19, 2006, aboard an Atlas V rocket. The primary mission was to survey Pluto, which was then considered the 10th planet from the Sun. It was also planned that New Horizons would visit Pluto's moons and objects in the Kuiper Belt. The mission was part of NASA's New Frontiers program to gather new scientific data about the still largely unexplored outer reaches of the solar system. New Horizons was the first spacecraft to explore Pluto up close, providing the first real pictures of the dwarf planet. Prior to this, all we had were artistic renderings and a somewhat blurry image taken by the Hubble Space Telescope. So, the first true encounter with Pluto was a landmark moment in space exploration. After a 9-year journey, New Horizons reached Pluto on July 14, 2015. To achieve this record time, NASA engineers used a flyby maneuver at Jupiter in 2007, using a gravity assist to increase speed by thousands of kilometers per second. What many people don't know is that New Horizons never swung into Pluto's orbit. The spacecraft just passed by, and the flyby lasted a few days, giving us fantastic images of Pluto's complex surface, pictures of massive ice sheets, glaciers, and possibly even cryovolcanoes. Volcanic designs amazed the specialists. Researchers had expected to find a desolate universe of rock and ice on Pluto. However, Pluto showed not only its popular heart but also an amazingly dynamic surface. The mountains on the planet are not made of rock but of ice, which is harder than rock on Earth. Cryovolcanism and dynamic ice fields led to the suspicion that Pluto, like the frigid moons Europa and Enceladus, is warm in its interior and potentially even has underground seas with simple types of life. New Horizons found that Pluto's environment is flimsy and consists of nitrogen, methane, and carbon monoxide. The test revealed that there are some climate peculiarities on Pluto, such as complex patterns of fluid and gas. Most likely, occasionally, snow-thick drops of nitrogen ice onto Pluto's surface. After this once-in-a-century mission, New Horizons delivered stunning data from Charon, Pluto's largest moon. Contrary to previous assumptions, Charon could be another small planet and not just a moon like its counterpart, Pluto. This moon showed a variety of geographical features, deep gorges and smooth fields, making the analysts want to study the Pluto system much further. However, that will have to wait. New Horizons couldn't wait at Charon and Pluto. The planned course took the probe further into the Kuiper Belt. This zone, behind Neptune and Pluto, is a few 100 million kilometers wide and contains a variety of rocky objects, home to some minor planets. On January 1, 2019, New Horizons successfully flew by Arrokoth, a particular Kuiper Belt object. This event sparked the great interest of specialists. The peculiar shape of two connected bodies provided scientists with significant insights into the dynamics that lead to the merging of objects, and this information could also explain how deformed small planets like Haumea or Makemake were formed. Now, do you also want to know where New Horizons is today? The probe is located roughly 8.2 billion kilometers from Earth, about 55 astronomical units, where 1 astronomical unit is the average distance between Earth and the Sun. New Horizons continues to move toward interstellar space. However, it will be many years before it even approaches the heliospheric limit. New Horizons likely still has enough energy to send scientific data until the 2040s, when the probe's energy source, a radioisotope generator, will be depleted. This probe will also continue to travel silently through the cosmos as a testament to our civilization. Subscribe now, as we regularly publish exciting new videos on space and astronomical research.